And now we want to move towards the basic criteria for determining similarities. What is the minimum information that I need to conclude that two triangles are similar to each other? And just like congruence, where we had figured out rules like SSS congruence or side angle side congruence or RHS congruence, that means if it is given to me that all three sides are equal, I can definitely say the triangles are congruent, and then all results open up for me, right? So we want to work out similar criteria. With what information, with what limited information can I conclude that the two triangles are similar? But before I can prove that, just a quick revision of what we did in the previous session, where we looked at the basic proportionality theorem. And let's say if you have a triangle ABC and I draw a line parallel to BC cutting across the triangle at DE, we concluded last time that this line, if it is parallel to BC, will divide the other two sides in the same ratio. That means AD upon DB, AD upon DV is going to be equal to AE upon EC. And obviously the converse of this result also, that if I know that the line is dividing the other two sides in the same ratio, it is going to be parallel to the other side. That means this angle is going to be equal to this angle. So why this is true, we have already worked out and also looked at a couple of other properties and related results. So by now we should know this well, because now as we try and work towards the proof of criteria, because it is very easy to say this is the criteria and use it in the future, but seeing the proof or the process of how it was derived really helps. One, you understand it better, and secondly, you remember it better because you've gone in a little depth and you spent a little time with it, if nothing else, right? So the proof we have already worked out, but this is a piece of information that we'll be using to figure out our criteria for similarities of triangles. So I hope you remember this. So let's try and understand criteria number 1, which is known as angle, angle, angle. That means if I give you two triangles, I say there is a triangle A, B, C, and I give you another triangle, and I give you that this is triangle PQR, and I tell you that angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. So angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. So only this information is given, because remember, if I have this information and I know the ratios of the corresponding sides is equal, I will obviously know that it is going to be similar. But I don't have that other piece of information, I have only this. So what can I derive or deduce from this? So to understand this, because these angles are identical, what I will do is I will pick up this triangle and put it and move it here. That means move this point A and superimpose it on point P. So because the angles are same, it's going to be something like this. This highlighted triangle is going to be A, B, C. So I picked up the triangle and moved it inside this particular triangle. And I have this information with me that all these angles are equal to each other. That means angle Q is equal to angle B. Angle R is equal to angle C. Angle B is equal to angle Q. Angle C is equal to angle R. If I have this information, now I can conclude that QR is parallel to BC. QR is parallel to BC. How can I do that? This is the transversal. These are the corresponding angles and they are equal to each other. Converse of our basic ideas with transversals and parallelograms. Now I have this information that QR is parallel to BC. That means this line is parallel to this line. And what did I just figure out in basic proportionality theorem? That if I have a line parallel to the third side, it will divide the other two sides in the same ratio. That means AB upon BQ is going to be the same as AC upon CR. And now I'm actually almost done, because remember what was my agenda? I already had this piece of information. So if I could prove that AB upon PQ, the corresponding sides, AC upon PR, and BC upon QR are equal, then I will have the angles are equal and the sides are in ratio, and I will definitely know that they are similar. But this information was not given to me, only this was given. I moved this around a little bit and I noticed this much: AB upon BQ is equal to PC upon CR. And remember, when we looked at basic proportionality theorem, another idea that we looked at was that if there is a line parallel to the third side, it is dividing the other two sides in the same ratio. That means AB upon BQ is the same as AC upon CR. Not only that, we also looked at AB upon AQ, AB upon PQ is also going to be equal to AC upon PR. The ratio of part to the whole is also going to be the same, and it's very easy to understand it. Why? Say if this ratio was 1:3, so this will also be 1:3, and if this ratio is 1:3, the ratio of 1 to the whole is going to be 1/4. The same thing is going to happen here also. That means I know the ratio of this to this and this to this is also going to be the same. That means, again, come back to the result that we have already written down. AB upon BQ is equal to AC upon AR. Part to part, I can also say part to whole, and instead of the whole, I will not call it AQ, I will call it PQ. So PQ, and AC upon CR, I will write AC upon PR, the whole thing, and I am done. AB upon PQ is equal to AC upon PR. AB upon PQ is equal to AC upon PR. Or at least I am half done with the problem. Now, how will I prove this thing? What I will do once again now is take this triangle and this time make it so that B matches with Q. Move this triangle here. B matches with Q. So you will have this line drawn here. And this would be A and this would be C. Just tilt your head a little. Once again you will figure out that these two angles are equal to each other. Angle C is equal to angle R. Angle A is equal to angle P. Once again making this line parallel to this side. Once again dividing the corresponding sides in the same ratio. That means the ratio of this to this is going to be the same as this to this. And once again from this to this, I can go to this to the whole is also going to be the same as this to the whole. Write it down once again and you will end up with the same result, that this is also going to be equal to BC upon QR. Maybe this part you can work out in a little more detail for yourself, but I hope the idea is clear. What this now means is I'm done with the proof. If I have the information that in two triangles all the angles are equal to each other, all the corresponding angles are equal to each other, you can definitely say that the triangles are similar. And what is the point of saying that they are similar? Because once you say they are similar, you can use this information to solve more problems or derive more theorems as needed.